Hello everyone, welcome to Python and AI Engineering for .NET Developer series. Coming from .NET, we are used to C# throwing structured exceptions when things go wrong. But in case of AI engineering, your code is not just dealing with any database constraint or network error, right? It's dealing with unpredictable LLM responses, sometimes very slow network calls, or the response takes very long time, get timeout. So today we are looking at lesson 4, error handling for AI system. And if you want to move your AI project, let's say from just an experimental project to production ready, then error handling is one of the most critical skill we need to learn. Right? So now let's start. So if we see how does the error handling works in both the C# and Python, it almost works in a similar way. Right? So we have a try block, and in C# we have a catch block, but in case of Python that's being called as except. Right? Now similarly, how we can catch any specific exception, then in the Python also we'll call except, then whatever the error we want to catch it. Right? One more good thing is Python has uh, additional one of the control called else. We'll come to that one in a bit, but which is not there in C#. But otherwise, the finally remains same. We have throw in case of C#. We have arrays in case of a Python. It's all works in a similar format. Okay, so now let's look into a code when the Python and C# code side by side comparison. The way we define the application, we have the try block, then except whatever error we want to handle it, and whatever error we don't want to handle it, and then it will have the finally, when finally will be executed even in case of a error or in case of no error execution. Exactly similar in C#, we will try, catch, and finally block. Now in Python there is one additional thing, as I told before, is called else. Else is kind of a success path. That means if your try block is executing without any error, then application will execute the else statement. In most of the practical cases, we tend not to use this one because it's as good as having a last statement within the try block. So like C#, we also define custom exceptions here in Python. It's almost similar way we define in the C#. That C# also have a base exception class. From that we can derive our own classes, and we use any kind of a business exception to throw, which can be differentiated from the technical or system exception, and which, for example, certain parameter is missing, some business validation failed, we want to throw a business exception. Something similar in Python, we have a exception class, then we can define our custom exception inheriting from the exception class, and then we can also within the constructor we can actually define the message, what are the any other parameter we want. It works exactly the same way how in C# or custom exception works. So whenever there is a exception occur, then we need to decide how does the application will behave next, right? So let's say we are making a API call, and from the LLM we are getting an error, let's say too many requests, right? So we need to wait for some time, then make an API call. For example, we are whenever getting error, let's say token, let's say maximum token or token exceeded, then maybe we have to show a different kind of message. For example, sometimes we may get an API error, we may have to handle differently, right? So in most of the use cases for LLM, we need to retry because LLM API sometimes may take quite a long bit of time to get a response. So if application fails, we need to have a mechanism to retry. Okay, so let's think if we want to retry an application error. In case of error, how should we write the code, right? For example, we have a method called API with retry, and there we want to make sure the system does maximum 3 type of retry, and only in case of some error, right? For example, here we say if the error is rate limit error, only in that case it will retry up to maximum 3 times. Now this is something typical pattern for most of the execution, be it API call, be it some other execution where retry is required. We need to do something like this, right? But we see here actual line of code is line number 6 and 7. But while all other codes from line number 2 to line number 21 are just a wrapper around the retry in try case and the retry mechanism, right? So Python, there is a very good package called Tenacity, so which actually does all of this internally. So application we don't have to write logic or handle retry ourselves, right? So we can install the package Tenacity, and then once you install the Tenacity package, Tenacity has quite a lot of let's say helper methods and one decorator called retry. So decorator is like an attribute in case of a C#. On top of method we sometimes define an attribute, right? and the attribute will change the way the method behaves, either the input or output, or during the exception handling, the attribute behave differently. So similarly in Python, that's called decorator. So retry decorator, there are various parameters are there. For our discussion here, we are using three parameters. One is stop, one is wait, one is retry. Stop is after how many attempts it will stop, which is 3. Wait is after while before retry another execution, how many seconds it needs to wait. And third one, in what scenario it will retry. Just to replicate the previous manual code, it will only retry in case of a rate limit error. So now with this decorator, my Python actual execution code, which will return the message, sorry, execute the LLM code, is very simple. It's just 2-3 line of code which actually makes the operation or perform the operation. It need not handle all those mechanisms. Okay. So now we look into few scenarios. One is how exceptions are handled, how do we create custom exceptions, and how do we use the tenacity package for retry. Now let's go back to Visual Studio. We'll try with one small example. How does this tenacity package and the retry mechanism get? So now let's create one folder for day 4, and then we start with that. So within day 4, let's create a file. Let's say 01 exception .py. Okay. So now let's first start with the tenacity package. Again, what we usually do, I'll just install tenacity. So for that, I'll first define the tenacity as part of my requirements.in. Then again, make sure we are within the venv virtual environment folder. Then we'll do the pip compile. Then we'll give the requirements.in file, which actually will create the requirements out file considering including the tenacity package. Then we need to do the pip sync, and we need to pass requirements the out file. So after doing this, it will automatically install the tenacity package. Now you see it's downloading, installing the tenacity package. So now once the tenacity package has been installed, let's go and write a small application, right? So we'll say, let's say from tenacity, we'll import retry, then we'll import, let's say, stop after attempt, then wait fix, and another one retry if exception type, right? So then let's call it, we'll create a simple base class. Okay, so let's say simulated exception, which is from the exception type. It will not do anything, it's just empty class for the demonstration purposes. So now what I'll do, I'll create a method. Okay, let's create a method, define, we'll say a function that may call, and there we'll just make a call to LLM, right? So let's say we'll call, okay, before that, let me call another method. Okay, function that may fail. Let's just simple, we'll write a message and then we raise the simulated exception. Okay? Now define our LLM API call, okay, which is similar, the caller, right? Let's say call LLM, okay. So then I'll just say, I'll just call the LLM and return response. Okay. So to call the LLM, we'll make a call to this function method which may fail, assuming this method is something we are calling as part of our function API call, right? Okay. So now what will happen whenever we call this LLM, it will try to make a call here and it will fail. So let's go to the day 4 and then we start with execution. Okay. So Python 01 exception keyword. Now when you go to exception keyword, yes. So what it does, call LLM would be triggered, but that failed because of the simulated exception. Okay. So now what we'll do, we'll see how does the retry and everything work. So on this particular method, which we want to be, we want to retry. So I'll put at the rate retry. So then we'll put the three different methods, sorry, function. One is stop after attempt, then we have the wait fix, and retry if the exception type is simulated exception. Function failed, and here I'll just raise a simple exception. Okay. So now let's call again, run the application, then we see how does the response sound. So if you see here, it's saying calling LLM. You see this particular execution line is coming from within the method. So if we see it here, so it called 3 times because we have given the retry 3 times. So it called 3 times the method, and then after 3 times, since it was still failing, so here it got the error, right? And even within the call, it waited for 1 second. Okay. So that's pretty much how we actually need to use the tenacity package and retry. and how tenacity package can help us to write a simple call with a built-in retry, wait, and handles only certain exception type, etc. are being called. So that's all for today. So what you understand, right? So proper error handling is actually the key difference while you write a experimental code or a production ready code. Okay, and how do we ensure application retries are already built in to your application code, so you don't have to make it retry is an afterthought. Okay? Okay, so then in next lesson, we'll look into the file operations environment variable. We'll look into one specific library called Pathly, which is a Python's file handling package. And also we'll compare with C Sharp path.combine, how do both work together. Everything we covered today, including the scripts, the configuration, the extended documentation, is available right now on TechWayFit.com. While you are there, check out our deep dives into various technical blogs like on enterprise security, design principle, or put your skills to the test with our develop focus quizzes. And if you're ready to master the intersection of the .NET and AI, subscribe to the channel and I'll see you in the next video. Thank you.